Welcome back, everyone. Let's welcome our next speaker, Nauvoo Perez, who will be presenting on beyond customers and marketing, utilizing data flow to process ultra large images. Well, these are very beautiful ones. Nauvoo is a cloud engineer at Mantel Group, working in ANTX, where she helps us forward with DevOps, IAM, and in data space. Yeah. By night, she can be found with a book in one hand and a calligraphy mic in the other. How do you do that? And her favorite ice cream flavor is cookies and cream. So let's talk now. Happy Filipino, everybody. I'm also Filipino, so I decided to incorporate Christmas just because Christmas starts in like the bare months in the Philippines. So thank you, Lovey. So just wanted to preface this off by saying I am not a Dataflow expert. I just like to dabble, so I've been working with Mantel Group, and fortunately enough, they allow us to like dabble into things that will interest us. So with that out of the way, let's get started. Agenda for today is pretty straightforward. I'll take you through a little bit of a like narcissistic journey on how I ended up going through this side project of mine. I'll talk to you about like why I decided to do this side project, some of the tools and some of the sources that you guys can like have into if this is something that you guys are interested in. We'll then talk about some technical stuff. I'll also be talking a little bit about cost sustainability. So I view this in the lens of like, if you're not rolling in money, is this I guess process financially viable for you? And then we'll do a final thoughts and wrap up. Oh, I forgot my age. Hold on. Okay, so just a little bit of the background. So where it all began. This is me back in 2020, 2021. I was fortunate enough to participate in an internship. So we did a bit of a research project there. My supervisor worked with the Olivia Newton-John Research Center. And so what I did was I focused on colorectal cancer, and so what I was doing was trying to identify whether like a certain type of white blood cell is found in the tumor or still in the I guess tissue, the organ. So I was very fortunate enough that we had access to amazing images, like really high quality. Now I had to be a little bit creative. It's because I don't have permission to like release those images. So this is me, and the images that I had access to was massive. So think 135,000 by 50,000. And so they're taking it at 40x magnification. So what these look like is like you have a very high level view of the tissue, but then when you keep scrolling in, you essentially work in like the cellular level. And so I thought that was really cool. Somebody sat down there and annotated the entire thing, and I decided to portray that as this very high tech rocket ship. So I had to be very realistic. I knew that no way would my computer have been able to process such a massive thing. So what I then did was I had to scale down from that, and then I ended up choosing this dimension. The reason for this is none. Very scientific, I know. I basically chose a random part of the image and I said, yep, this looks good. This has the tumor, this has the tissue, this has white blood cells. Necrotic tissues, excellent. So I went and I did a fair bit of like image analysis on this on that portion of the image, and this is what it looked like. A sword, realistic but still fantastical because it's floating. Even at this level, unfortunately, I still couldn't get any good insights. So this was despite me using my brother's computer at the time, which I think rocked higher than a 1080 graphics card, which was way better than the big budget uni computer that I had access to. I got towards the end of my internship, and I've got the finish line over here, and I ended up with 3 images. And this is what the images I feel look like. 3 sticks. It was very unfortunate. It's because at this level, it was actually starting to get really interesting. you can actually start to determine like whether something is a white blood cell. So like even with an untrained eye such as myself, I can actually be like, oh, that's pretty cool. That actually looks like something different to like the other blood cells around in the image. But even in so the problem here was processing. So I did like k-means, other like image extraction algorithm that I found that I had access to. But processing each of these images took approximately one episode of Overlander or Outlander. Anybody know that show? Anyways, Jamie, yay. So yeah, it approximately took me like one episode to process that. So it's not very viable. And so that's sort of like this entire thing. I'm like, what would I have done better had I known what I now know? So this is what a histology slide looks like. So this is a lung tissue that I got from the Cancer Imaging Archive. And I want to show you guys how much detail is actually in this image. So if you like scroll in, like this little part over here. Oh yes, you can see my mouse. Excellent. So that little part over there. This is actually what that looks like. So when you're working at this scale, what you basically want to keep in mind is you don't want to do any premature like image compression. It's because when you go further down into your pipeline, when you're working with things like algorithms that check the pixel of its neighbors, you're going to like really affect the outcome of that if you're doing premature compression at this stage. So my entire spiel today is how do we get this amount of like data ready for cloud processing. So my title should really be pre-processing. Anyways, my entire process and my brilliant idea is what we do is we chunk them. So that's the entire like pipeline that I'll be working you through today. Okay. Oh, work. Yes, excellent. Here we go. So before we go into looking into code, since this is a beginner class or session, I thought we should do a Data 101. So what is Dataflow? Dataflow is a cloud, Google Cloud service that provides unified stream and batch data processing at scale. Dataflow can be used to create data pipelines that read from one or more sources, transform the data, and then write the data to a destination. And then these are like some of the typical use cases for Dataflow. So something like ETL, extract, conform, and then load, or applying ML in real time to streaming data. So a bunch of words, some things that stand out to me personally. Stream and batch data processing. So what this means is Dataflow doesn't really care whether you're working with batch or streaming data, it can handle both. The second sentence is essentially what Dataflow expects from you. It expects you to write that it'll be reading your source from somewhere. It expects you to write code that will transform your stuff, your data, and then you have to output that somewhere. So those are your three things that you're looking for. If you're working on something and you're like, ooh, is Dataflow something I should consider? What I like to think about is your data can you chop out your data and can they then be processed independently of each other? Obviously, you can aggregate them, but if they can be processed independently of each other, think about Dataflow. It might be what your application needs. I've also added a bit of vocabulary since we are all beginners here. So Apache Beam, it is basically impossible to talk about Dataflow without coming across Apache Beam because essentially that is what it runs. So Apache Beam is essentially the framework in which you write your code. So you can write it in Java, Python, Go. Those are the three main ones that I know. Definitely it will support other stuff. You then give your code to your runners if you think of them as orchestrators. So what they essentially do is they then go and translate essentially your code into what your workers or your which are essentially just virtual machines into what they can execute. For the runners in this thing that I worked on, there are two main ones. So we've got direct runners, and that's the one that you use while you're like in your main developing phase. And that just allows you to run your pipeline on your local machine. And the second one is your Dataflow runner. I guess it's a little bit confusing. It's because there's Dataflow runners, and then you've got Dataflow as the GCP service. So just keep that in mind. Once you're ready to give it to GCP, you then use your Dataflow runners. P-collections, so how I like to think of them are they're basically the most basic unit that you'll be working on in your pipeline. So you remember how I said, can your data then be chunked? Think of those chunks as your P-collection. It can change shape, and you can define what your P-collection looks like. So if you're processing an entire library, during your pipeline, it might start off as a book. Your P-collection might be a bunch of books. And then it can maybe transform into pages, or maybe you'd be like, oh, I want to know how many colors a certain author has, like the binding of the book, right? So you can change the shape of that. It really depends on you. Polydo is a type of transformation, so it's per element transformation. Par is parallel. I don't know what the do is. So what I like to think of it is do transformation on each of these elements in parallel. There's your polydo. Aggregation, again a transformation, but more concerned about combining and summarizing. This one sort of expects a bit of like key value pair. And so I remember when I was working on my first pipeline, it was Java, and it would not let me do certain aggregations, and it was because of that. So if you're coming across certain errors, check to see if the shape of your P collection is like apt for whatever method or transforming you're trying to do with it. Finally, code, guys. Okay, here we go. So this is the folder structure that I ended up with. So we'll tackle them one by one, but for now, I want you guys to take a look at my main.py, which is my main entry point, and then I've got a folder in that, which is this source, and inside it is my ingest.py, which is where I've got my pipeline defined. Okay, so this is my main.py. I've got a main run. So in run, I've got my pipeline options. If you're running Dataflow pipelines, essentially it expects a few things. So some of these are non-negotiable, and I think the first 5 months are the most important. This is the runner portion that I mentioned. So over here I've got Dataflow, but you want to initially start working with direct runners, and then once you're happy, bang, Dataflow, GCP, here you go. Alright, so another one, machine type isn't really something that is mandatory, but I feel is important. It's because one thing about Dataflow, it's scary because it has potential to run your bill way high. And so to mitigate that, we'll be like, just give us one of your most basic machines, and we'll work with it. Next one is your number of workers, so we want to make sure we have it. I want to raise a note on this one. It allows you to run a parameter that just says num workers. You don't want that, guys. You want to cap it. Well, I guess you can work with that one, but still, we're mindful of pace, of money, and the rest we'll walk through later. Going further down here, we've got my input file, and this is essentially the image that I showed you guys earlier. As you can see, I have it stored in a GCS bucket. Output bucket is where my stuff will get rewritten to, and this is the entire thing here, right? My main thing is I want to chunk stuff. And so it's just 256. You guys choose whichever one you want to use, how many pixels. I just chose 256. And then we go down here, and essentially this is the entrance to our pipeline definition. So ingest run image ingest. This ingest comes from up here, so we just go and import that source folder which contains our ingest.py. Going into our ingest.py, this is basically the definition of my pipeline. Run image ingest over here, and as you can see, I've got some sort of read, I've got some sort of transformation, and I've got some sort of write. I did have a bunch of code, but I didn't know how to fit it in, and I'm not very brave like Liam, so I was like, live demo, what's that? Too scary. So I've just written sort of like the steps. Did I use LLMs to write this? 110,000%, yes. You do need to know what you are doing though at the end of the day. It's because if you look down here, it says read input files. Well, that's wrong. Did I change it? Not really. The reason for that is beam.create actually doesn't read anything. It just creates your P collection. And so when it comes to LLMs, this is just a good reminder, guys. Use them, but don't forget to interrogate the stuff it spits out. Okay, so the biggest bulk of work that happens in this pipeline happens in this process image. So first off, it takes the P collection and then it downloads the image from GCS, and then you load the image locally using PyVis. So PyVis is the library that I ended up going with to process my image. Two reasons for that is that it has access to lossless methods. So basically what that means is, if you remember earlier today I said, no parameter compression. PyVis has methods that allow you to do that. So they allow you to zoom, which is lossless compared to like resizing. If you want to like zoom into a certain part of your image, it allows you to do that. Another cool thing about PyVis is it actually allows you to work on the image in sections. So basically what that means is it will never hold the entire image in memory, but rather only the part that you're working with. So that's sort of where like this batch size comes into play. So what I'm saying over here is work on this image and chunk it, but only do it in 1,000 pixel increments. So once that batch is done, it's been chunked, it gets written to GCS, and then your memory or your buffer gets wiped clean, and then it works on the other one. And so what that means for us is our little N1 standard for machine becomes sufficient. It becomes enough. It's because we never hold a lot of information in storage. The rest of the pipeline is pretty straightforward. What I end up doing is I end up like outputting this little directory that I then output into a file layer. And the reason for that is I will end up with a bunch of like chunks of my image. I need a way to manage to stitch those all back together. Did I do that in this presentation? No, I didn't. But I thought about it. So that's how you do it. So you then have all the information that you want once you're done with all your image analysis. Trying to get insights, doing ML, whatever, you can then now stitch it all back together, and then you're a happy little camera. Everything's working in your local, you're like, okay, let me try and see if I can run this on Dataflow. My recommendation is please check the calculator. So some of these you will definitely have to guesstimate. One of them would be the number of run errors. I actually tried to execute, I didn't try, I did execute this pipeline in my machine, and it took 13 hours to complete. It ended up with 13,000 files, it took 13 hours. So that's why I put 13. And then number of worker nodes. So this is pretty significant. If you take a look at the pricing, the difference between 15 and 10 worker nodes is pretty significant. I think with 15 it was roughly around $80. With 10 it was like 50. I'm like, listen, $80 seems a bit steep for GCP, but $50 I can do 2 less takeaways this month. So that's what I ended up with 10 worker nodes. Also, if you guys are using certain like options over here specifically, another one is where is it? Job types. Just make sure that you guys end up passing that into your pipeline. That way you are submitting that type of job. So redocumentation. You're gonna try to do everything that I said, and your stuff will fail. And the reason for that is because of dependency. You need to handle your dependency if you work with Java. I think Maven, and then you create your fat jobs and stuff. This in Python, this is what it looks like. You just need your setup.py. The thing that is important here is find packages. And so one of the issues that you'll find will be like, module does not exist, source cannot be found, it doesn't know what src is. And so that's why you need to do this init.py, and that's how essentially your setup.py figures out that it needs to look in there. Why does it look like I put my my requirements.txt in here? Because working with PyVis was a pain. I am that you do not need to do this. If you are only working with Python dependencies, I think this will be sufficient. But if you have further requirements, like you do when working with PyBits, it will not be enough, and I think you can remove this. Did I remove it? Of course I did, because let me clean up, guys. So if you're working on things that require additional steps, my recommendation is go create your own custom container. Very straightforward, you've got your Docker file. So you've got your SDK over here, which is essentially the Apache Beam version that you want. So if you're somebody like me that has this number in 3 places, I had them in my Docker file, I have them in my requirements.txt, and I have them in my setup.py. Make sure all those numbers are correct, it's because you will pull your hair out. Also remember where you put those versions, because you will put it already checked everywhere. But no, you haven't. So this then allowed me, by creating my own custom container, I can then run libviz, because if you are working with PyBits, libviz would be an issue. So yes, there's that. I hope it doesn't happen to you. Another thing that you will come across is wheel. I don't know, but I think if you don't require libviz, this will be sufficient. Just putting wheel here is because when I was checking out Jamie, they were like, wheel was completely successfully created for Jamie. But for some reason, I needed to put it in my Docker file again. An issue that I have when I was working with my Docker file is I could not see logging. So what will happen is when you submit this to Dataflow, it'll be like, yes, we have received your job successfully and we are spinning up 5 workers for you. And so if you're familiar with Dataflow, you look at your 2 logging areas. So one is for your job and that one will still have output. And then if you look to your workers, it'll be blank, nothing, absolutely nothing. So what worked for me was I had to put in this Cloud's Ops agent repo and then install this cloud logging and then Google Fluent too. I don't know what that is, but that's basically what I needed to get logging working for me. So if you come across an issue in dealing with logging, check this one out and that might work for you. This would be, running this entire thing, by the way, took me 7 minutes compared to my 13 hours. So would I recommend it? Yes, absolutely. You've got 13,000 files that you can now play around with in GCS. You don't need to do it over and over again and save yourself hours. All right, so this is my do-over workflow if I had the chance. Somebody would be like, oh, hang on, I'll do that. Looks like ELT. You mentioned ETL. And the reason is, yes, I hear you, child, but the reason for that is we are in development. We do not want to keep on ingesting our 13,000 files over and over again. So what you do is, what I did was basically this pre-parsing thing did, right? And then the stuff that I talked about earlier during my narcissistic memory, walk down memory lane was this transformation. And so what you can then do is you can then grab your snippet, your little chunk, and then you can process that either locally or you can use cloud functions. I would love to use cloud functions because maybe then it doesn't need to take an entire episode of me watching Jamie talk about Claire. So that's what I would do. Otherwise, if I'm happy with that, I'll then just read it through all my Dataflow, and then my little 13,000 files, they now become my new P collection. Another thing is that you have it in GCS now, you can do external tables that is going to feed into your BigQuery. And then from BigQuery, bam, right in there, SQL, you've got ML code. So really, once you're there, you can do whatever you want. And then this is the cleanup bit that I mentioned earlier, where you already have all the necessary information that you need to stitch everything back up. All right, here we go, paper dollar bills. If some of you are not familiar, this is what billing in GCP looks like. You can do your custom rate, and if you're like me, using your company's resources, you can also just say, yeah, I'm only interested in the money of my particular project. Would I recommend using Dataflow? Yes, as you can see, it costs me less than $3 to run the entire thing. And this includes multiple successes on tiny little example images that I was doing my testing on, and it includes way too many fingers as well. And all of that is accounted in this less than $3. So, having said this, why did I still recommend going into the calculator? Because you might need it. You might not be as lucky as I am, and then you're like, oh, that is ridiculous. So yes, always check, but it's probably likely that you won't end up spending $50. Alright, wrap up and final thoughts. So process the image in batches to save memory, and that will allow you to use smaller worker machines, saving you money. But also, this idea isn't very original. As a matter of fact, I sort of borrowed this idea from a concept of windowing, which is something that you will need if you are interested in working in streaming data. So, if you end up working in streaming data, be like, oh, now I'm going to mention this. Another one is executing a Dataflow job in a custom container. If you guys aren't very confident in using Dockerfile, she's easy. Not managed to do it. Amazing. But also, I was looking at this thing called Flex template that they have in Dataflow. So if it was something that was a little bit intimidating to you, I know they use Dockerfile, so just be like, oh, now it's less intimidating. Final thoughts is learn how to write prompts. Most of this was written in LLMs. Give it a persona. Be like, you are an amazing Google Cloud developer. Write me code. Give it a persona. That helps. Also, learn how to sorry, Mantel is like a consulting firm, and so I work with a lot of people. I'm really surprised by the quality of how some people either Google or use LLMs. If you think they're good, you know, there's no point, but oh, excellent. Okay. If you think they're good, that's fine. But also just be like, oh, maybe I should brush up. Maybe I'm not that good, but I'm not here to crush your confidence, guys. You probably know already good. Despite working with LLMs, documentation and search engines are still your friends. Because LLMs lead you down a rabbit hole, maybe the answer is sometimes just the first result in Googling something. And that's it. Thank you very much. Any questions? Awesome. Oh, yeah.
Well, I gotta ask.
Do
I have a microphone? So if you were doing like neighboring pixel kind of calculations and you were chunked, did you have any, I don't know, did you do that twice with different chunking sizes to cover the chunk to chunk?
Yeah, honestly,
pixels?
when I did my presentation, my research, I wasn't even sure how I got to those specific like dimensions. I was like, yeah, that looks good enough. But I was thinking about it the other day, and I was like, did I do it properly and crop it, or did I just do a screen grab? I'm not sure. So with regards to your question of like, how would you handle that? Honestly, I don't know. Like, I haven't thought that far into it. But yeah, no, it's a really good point. It's because how will you then determine, because it is the edge, right? So then how does it then know that the next one might be related? Honestly, I've got no idea. But if you end up thinking about it, reach out to LinkedIn. I would love to hear your thoughts. Any other questions? Yes.
So I think it has limitation for the distributed computation, right? So as you mentioned, like if you're doing pixel computation, things like pixel labels like this are independent of each other. So you have to decide the chunk size. So the most suitable job type, it will be like if you consider your job is totally independent of each other, then the cloud might be suitable for us? Is that?
Sorry, what was the question, sir?
So I think like not all of the types of job, not all job types are suitable for this cloud computation, right? So once if your job are dependent with each other, requires kind of other memories in another node, so it will be not that suitable. So we have to, before use that, we have to decide which job type is suitable for this computation.
Yeah, absolutely. I think, but that would also be just like choosing whichever tools that you're using, right? I'm not sure if I'm answering your question appropriately, and if I'm not, I apologize. But I think when it comes to choosing whether this is a tool that you would like to use in your application, obviously you'd have your discovery phase or your initial thinking when you're just by yourself, whether this is appropriate. So if they are independent of each other, then maybe it's not the best tool for you. You can maybe just create something in like Cloud Run, and then that way you don't need to like split things up, right? If they've got more dependencies and all that stuff, maybe Cloud Run is better for you. Honestly, that entire workflow can just run in Cloud Run. It's because my P collection never changed. It was just one image being processed. To actually make that a bit more better for Dataflow, I actually would like, how I had like the batches? I would actually turn those batches into pre-collection so that you can work them in parallel and then chunk them up in parallel. But if something needs more dependencies and then you're saying like, I need that information from the other place, then maybe it's not appropriate for you, and that's completely okay.
Yeah, okay, thanks.
Any more questions? If not, then thank you so much.